Hello everyone, this is Mrs. Cooper.
And this is Mrs. Backus.
And this is our video on scientific notation.
So I hope you get a paper and pencil out and follow along with us. We're going to have some fun.
So let's begin. What is scientific notation? Now this is a short way of writing numbers that are either too big or too small. It is written in the format a times 10 raised to the power of b. And here we have that a would be our decimal number, which is between 1 and 10, and b will be our exponent.
So let's try some examples so we know what we're doing. So if we're going to convert a number into scientific notation, let's take a look at our number. This is too big. So we want to make this number more reasonable to deal with. So I'm going to look at the non-zero numbers, this 4, 6, 7, and I need that to be a number between 1 and 10. So I need to put the decimal right here and change that to 4.67. So in front of the decimal, I only have one number. So I've moved the decimal. So if I've moved the decimal, I also have to tell how many places I moved the decimal and multiply it by 10. So I'm going to go back in here, and you notice there's no decimal here, but there really is an implied decimal. So if the decimal's over here, what did I do to this number? I moved it 1, 2, 3, 4, 5, 6, 7, 8 places. So my answer ends up to be 4.67 times 10 to the 8th. Anytime you move the decimal point to the left, the exponent is going to be positive. You might also think about that as if you're going to have a big number like 467 million, you're going to need an exponent that is positive.
Now here we have another example, and in this case we're dealing with a number that is very small. So to convert it into scientific notation, first we look at the non-zero numbers, which are 3 and 8, and we have to make this into a number that's between 1 and 10. So in this case it's 3.8. Now you see that we have to put the decimal point right here, so we get 3.8, and that means that our decimal point that started here had to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the right. So here we get our answer will be 3.8 times 10 to the negative 10. Now we notice a difference with the other example. This has a negative sign right here. That's because we moved the decimal point from the left to the right. When you're dealing with small numbers, you will get your exponent will have a negative for an answer.
So let's try another example. Here we have 9.34 times 10 to the 5th. It's already in scientific notation. What if I want to go the other direction? What if I don't want it in scientific notation? So times 10 to the 5th tells me that it should have been a pretty big number. So I'm going to move my decimal to the right, and I need to move it the exponent number of times, so 5 times. So it's right here. I'm going to move it 5 times. 1, 2, and now I have to keep moving it 3 more times. So I'm going to add 3 zeros. So you can kind of see it better here. It used to be here, the decimal point, and I'm going to move it over 1, 2, 3, 4, 5 places. So now my number is 934,000. I moved the decimal point to the right, so the exponent is going to be positive. You can also think about it. This tells me it's a big number, and I should end up with a big number. If you end up with a very small number, you know you've made a mistake.
In this example, we also begin with a number in scientific notation, but in this case we see that the exponent has a negative sign, so this means it's a small number. So to convert it into a decimal number, we take this 3.02 and we will move the decimal point, the number of places stated by the exponent, which is 3, and we will move it to the left. That's what the negative sign tells us. So we can actually see it better here. The decimal point used to be here, and we will move it 3 spaces to the left. 1, 2, 3. So this is our answer in a decimal format. Now you see that the number was small and we ended up with a small number, so that means that our answer is correct.
All right, so let's convert into proper scientific notation. So we said the number in front of times 10 to the exponent had to be a number between 1 and 10. Well, 718 is not a number between 1 and 10.
It's
right?
quite big.
It's
yeah.
quite big. It's way too big. So they moved the decimal not enough places. So it should have been after the 7. It shouldn't be 71.8. It shouldn't be 718. It shouldn't be 0.718,
No.
right, Mrs. Cooper?
No, that's smaller than 1.
That's smaller than 1, so it should be 7.18. The number in front of the decimal has to be between 1 and 9. So here's my number. So what did I do? I moved it over 2 more places. So 2 more places. So I have to add 2 more exponents to my number times 10 to the 28th. So notice if the decimal is now smaller, the exponent should be bigger. So because I moved it to the left some more places, I had to add some more exponents, right?
That's right. That's correct. And here we have another example with a small number. So again, this is not proper scientific notation because
that's wrong, isn't it?
it is very wrong. So here we need to fix this to make it into a proper scientific notation format. And Ms. Backus, is this number smaller or bigger than something between 1 and 10?
That's much smaller.
Very, very small, right? So we actually need to move this decimal point right here between the 6 and the 7, so it can be 6.7. That's a number between 1 and 10. But when we move it, you see we have to move it 1, 2, 3 spaces to the right. So that means that here, if my decimal is now bigger, so my exponent will be smaller. We're doing the opposite. So I will subtract 3 from 10, and I will get a -7. Or actually, you're kind of like adding because of the negative signs there.
Wow. All right, let's try one more thing. How am I going to do this on my calculator, Mrs. Cooper?
Yeah, so when we're dealing with these big numbers, you won't be performing your calculations by hand. You will be using your calculator. So I believe everyone is using this calculator, the Inspire. And you will notice that right here, there's an exponent button. It's EE. So when you're typing this, for example, we have a multiplication. When you're using the calculator on your screen, you will write the number 4.89, and then instead of writing times 10 with a caret, that's sometimes you did that before, we're gonna switch and we're gonna use the exponent button, which is EE. So we will substitute times 10 with the exponent button and then write the number right here, 27. And then you click on the times button and then do the other number, 1.03, and then EE and -12. Remember to include the negative sign if you have one in your exponent. And that should give you your answer.
So, Mrs. Cooper, if I've been using times 10 to the caret button, can I still use it?
It's better if you don't use it because sometimes we can make mistakes, especially when we're dealing with order of operations. And if you have a division or something that's not as simple as this example, this multiplication, you might get the wrong answer. So it's better, and I think the most acceptable thing to do is to use your EE button in your calculator.
All right, I'll use that from now on.
Okay, very good. Now what happens if you don't have this calculator? Well, you have to check if what's the proper way to click on it. Yeah, because sometimes calculators don't have this button. So check in your manual or check with your teacher if you have to use the EXP button or a second EE or something like that.
All right, so we'll check with you in class if I don't have the TI Inspire.
Okay, very good.
All right, well, thanks for listening. It's Mrs. Cooper's first video, so you should give her a round of applause. But she'll be making lots more.
Yes.
So did you have fun?
Yes, I did.
All right, thanks for listening.
See you later.